So let us first proceed with our vectors. We shall compensate for tomorrow. We shall have 2 lessons. I hope you will be fine with it. Okay. So today we want to introduce what we call equations of lines, or the vector equation of a line. The vector equation of a line. If you have a straight line from our O-level and primary, we have seen that straight lines have one definition that is defining them. One, you'll find that straight lines do have at least 2 points that connect them. Okay, so if a straight line has at least 2 points that connects them, then it means that one of the things one needs is that you should at least have 2 points to make one line. For example, if I had 1 point here, another point here, then to make this line, I would pass through here like this. This would define a line, having a point A and a point B. This implies that for one to get a line, you require a minimum of 2 points. Now, in vectors, we have what we call position vectors. So in vectors, we use position vectors. The position vectors are defined by the coordinates you know. Those coordinates you know predict position what? Vectors. So the vector equation of a line in space vector equation of a line in space, we are going to consider a line, but this line has a reference from the origin, and we shall have a point here, a point A, we shall have another point here, a point B, whereby point A is defined by the position vector small a, point B is defined by a small vector, position vector small b. And according to that, if there is another vector which is parallel to AB, remember last time we saw parallel vectors, okay? So if there is a vector here, it means AB is going to be equal to a scalar multiplier times a vector D which is parallel. So this is a vector D which is parallel to AB. Now, if that is the case, we shall need to identify a position. If B is known and this AB is unknown, maybe it is X, Y, Z, it is an arbitrary point, then from the definition of AB is the direction vector. So from AB is equal to OB minus OA. Then we can see that OB is equal to AB plus OA. But OB is defined by X, Y, Z, which is unknown. So this is X, Y, Z. Let me call this OB actually R. an arbitrary point. Then AB we have seen is equal to lambda times D. Then OA is already known. Now this means that X, Y, Z, an arbitrary point that lies on the line, is equal to a known point with the position vector A on the line. So we assume this A is already known. This is a known point. This one is an unknown what? An unknown point. So the unknown point can be found by using any known point on the line with position vector A plus lambda times the direction vector D. But this position vector of the unknown point can be called R, which is X, Y, Z, and therefore in general, R is going to be equal to a known position vector A plus lambda times D. And this gives us what we call the vector equation of a line. This is what they call the vector equation of a line, where D is what we shall call the direction vector of the line. Then lambda is a scalar what? Multiplier. Then A is the position vector of any point known on the line. So that is the definition of the vector equation of the line. If A is known, if A is known as, for example, as x1, y1, z1, and D is known as L, M, N, and we have seen the arbitrary point is always unknown, unknown X, unknown Y, unknown Z. Then X, Y, Z, which is our R, will give me the known point, which is X1, Y1, Z1, plus lambda of L, M, and N. Then, if I substitute and make lambda the subject, I'll have X. If I equate the i's around, this X is equal to X1 plus L times lambda. So X is equal to X1 plus lambda times L, equation 1. Then Y is equal to Y1 plus lambda times M. This is equation 2. Then Z is equal to Z1 plus lambda times N. This is equation 3. I can make lambda the subject from here and say lambda is equal to X minus X1 divided by L. Then on this second one, lambda is equal to Y minus Y1 all over M. Then the last one, Y is equal to Z minus Z1 all is over N. All these three called parametric equations of a line. So you can note that down. Those ones are called parametric equations of a line. So if they are called parametric equations of a line, it is from those parametric equations of a line that we get what we call the Cartesian equation of a line. So after that, we are going to get what we call the Cartesian equation of a line. Okay, so I trust that you're done with that. Now, those are parametric equations. For us to get the Cartesian equation, they can ask you to get the Cartesian equation of a line. The Cartesian equation of a line, since we have seen lambda is equal to x minus x1 over L, and lambda is equal to y minus y1 over m, and lambda is equal to z minus z1 over n, then we equate all these three together. When you equate them, you have x minus x1 over L is equal to y minus y1 over m is equal to z minus z1 over n, where x1, y1, z1 are coordinates of a known point on the line. Then L, M, N, this one is not supposed to be written like this. It is always only written in either IJK or in column form. This is a direction what? Vector of the line. You said you have a question bank, eh?
Yeah.
You will find there these questions asking you to identify the direction vector of the line, do this for the line, and so much and so forth. So those are the basic definitions of a line. Now, note, the most important thing about a line is its direction vector. D. That is the most important thing about a line. It is its direction vector. What? D. So you have to know that whatever they ask you, besides finding the equation, when they say a line and another line, a line and a plane, a line and this, a line at this angle, whatever they are talking about, they have tilted or they are dealing with the direction what? Vector of that line. An example. Find the equation of a straight line. Find the equation of a straight line. Passing through the point. Passing through the point. 5, -3, -7, and is parallel to the vector 2i minus 3j plus k. Now, if this is the line and it is parallel to this vector, that vector it is parallel to is the d. So it means d is the direction vector, which is supposed to be 2i minus 3j plus k. Then the known point A is going to be 5, -3, -7. Then they never specified, they just said find the equation. So you find N. So you can either use the Cartesian equation or use the vector equation. Let me start with the vector equation. The vector equation is A plus lambda D. So R is going to be equal to 5, -3, -7, plus lambda times 2, -3, 1. This alone is the answer. You don't substitute for lambda, you leave lambda in your answer all the time. So that this tells you that this is the D, then this is the known point. You'll find questions set in this form. 5 plus 2 lambda, -3 minus 3 lambda, -7 plus lambda. This is also another correct form. This is correct, this is correct. They are all describing the vector equation of a line. You will find another book having like this, X, Y, Z. X, Y, Z represents the position vector of R, which is an arbitrary point on the line. So it can also be written as 5 plus 2 lambda, -3 minus 3 lambda, -7 plus lambda. So this becomes your job to redesign it in this form, to take it back in that format. Now, what if they had asked you to get the Cartesian equation, which is method 2? The Cartesian equation is going to be, remember I showed you that x minus x1 over L is equal to y minus y1 over m is equal to z minus z1 over n. So you would get x minus, the known point has a corresponding x of 5 over L, which is the which is what? 2 is equal to y minus 3 over m. M, because now if D, you have realized is 2 negative 3, 1, this means this is L, M what? N. So L is 2, M is negative 3, and N is 1. Now, the question is going to be this funny. The final answer becomes x minus 5 over 2 is equal to y plus 3 over negative 3 is equal to z plus 7 over 1. And this is our answer. In Cartesian form. Now, they will set a question in Cartesian form. Then they ask you for one. Find the direction vector of the line. You see the direction vector is the bottom, which is 2 negative 3, 1 answer. But they might put that negative up. If they put the negative up, the answer will look like this. X minus 5 over 2 is equal to negative y minus 3 over 3 is equal to z plus 7 over 1. It is your job to make sure that the y behaves like this y without a negative. Even the x should not have a negative. Even the z should not have a negative. That is the general definition. So if you land on a question which has a negative, make sure you remove that negative and perhaps take it down in the direction what? Vector. Otherwise, you might get wrong answers. Okay. Any question on those two methods of solving that number? Otherwise, that is the problem. Yes, please.
This negative y.
Which negative?
Doesn't affect this on the last one, the Cartesian
equation.
The negative y minus 3 out of 3.
How it came about?
No, when you're changing it, like when you're taking the negative down to like how are you going to bring the negative down to 3 and make the y a positive?
Yeah, okay. Should I work it backwards? This is what is going to happen. You factorize the y, the negative, and you get plus 3, right? Then down there is a what? A 3. Then this negative can come down. You just divide by a negative up and a negative where? Down. Becomes a positive, then down you acquire a negative. You better check your enable question bank and we see if we have some value, some question there.
Okay.
A question which has a Cartesian equation, eh? Let me also check here in my books. Yeah, I've seen one. Find the angle of intersection. Okay, I just wanted to explain that part. Let me just extract this because it's not the question. I was trying to put up one. So we have x plus 1 over 2 is equal to y minus 3 over 5 is equal to z plus 1 over negative 1. Find the direction vector of the line. Find the direction vector of the line. Hence, express it in vector form. So we have x plus 2 plus 1 over 2 is equal to y minus 3 over 5 is equal to z plus 1 over negative 1. Now, firstly, we need to find the vector equation of the line, but we need to find the direction vector. So I've told you cannot find the direction vector before first extracting out. Okay, this one was not clear. But anyway, in case you have this, it's the same as x minus minus 1 over 2 is equal to y minus 3, that one is okay, is equal to z minus minus 1 over negative 1. So the direction vector straight away is 2, 5, negative 1. The known point A, a vector, is going to be negative 1, 3, negative 1. Therefore, the vector equation of a line is got from A plus lambda what? D. Thus, R will be negative 1, 3, negative 1 plus lambda times 2, 5, negative 1. So this is the vector equation of the line. Let me see if I can get another better one for extraction. Okay, I've got this one. Says x is equal to 2 minus y over 2 is equal to z minus 5 over 1. Now, when you look at when you look at that what? When you look at that equation, it looks as if it's not complete. But I want to show you how to extract it back. It is the same as saying x minus 0 over 1 is going to be equal to, now factor out the negative, you will realize y minus 2. Do you see that? Then divide by 2, not so. This is going to give us z minus 5 over 1. But finally, this becomes x minus 0 over 1 is equal to y minus 2 over negative 2 is equal to z minus 5 out of 1. So therefore, our direction vector is going to be 1, negative 2, 1. Our known point is going to be 0, 2, 5. Okay?
Yes.
So you're going to try out for me this, extract out for me, 1, the direction vector, and also tell me the known point. So give me the direction vector and also give me the known point. So do you have an answer?
I'm still getting.
Okay. Hello? Hello?
Got A is equal to 0, 1, 1.
The point is 0, 1, 1. Correct? Yeah, correct. That is correct. For the known point, it is 0, 1, 1. So A is equal to 0, 1, 1. Or the point, you can write it as point, for example, A, 0, 1, 1. That one is allowed to be written like a point.
Then the direction vector, negative. -2, -1, -3.
-2, -1, -3. Correct. Okay. So having gotten those definitions, the other definitions we can find. 1, angle between two lines. So you have an angle there. You can have an angle theta. You can have an angle alpha, where alpha is obtuse, theta is acute. So they can ask you to find the acute angle between two lines, or they can ask you to find the obtuse angle between two lines. Remember I told you the most important thing about a line is what? What is this most important thing?
Direction.
The direction what? Vector. So you always use the direction vector to predict most of these items asked for. So it means one line will have a direction vector, D1. This other line will have a direction vector, D2. So it's the same as getting the direction vector D1, dot it with the direction vector D2, and use the dot scalar product to find the angle between them. So, in case you have those direction vectors, then you can always use this definition to find the angle. So cosine of theta is equal to d1 d2 divided by magnitude of d1 magnitude of d2. So theta will be equal to cos arc of d1 dotted with d2 all divided by the magnitude of d1 and the magnitude of d2. And with that definition, we can have an example. Find the angle between the following pair of lines, x minus 2 out of negative 4 is equal to y minus 3 out of 3 is equal to z plus 1 out of negative 1. And the second line is x minus 3 out of 2 is equal to y minus 1 out of 6 is equal to z plus 1 out of negative 5. So, our first equation has a direction vector d1. d1 is going to be equal to negative 4, 3, negative 1. Can you identify for me the direction vector for the second line?
Two,
Two.
6 and 5.
Why are you saying 5?
It's z plus 1, so you factor out the negative and
You don't need to factor out the negative as long as z is positive. You get it, eh? Yeah, are you seeing that?
Z.
It is x minus 3 over 2 is equal to y minus 1 over 6 is equal to z minus 1 over
negative 5.
Over 5. No, this one is for the known point. This negative 1 is for the known point. So the known point in that case would be 3, 1, negative 1. You only take down the negative if the z is negative, or y is negative, or x is what? Negative. Besides that, you leave them as they are. When you do that factorization, it goes in the known point. So this will remain as it is. So the definition says you dot d1 with d2 to give us magnitude of d1, magnitude of d2, cosine of the angle between them. So this will give me -4, 3, -1.
Wait, teacher.
Mm.
He said it remains as it is.
Hey, it had a -5. Eh?
Yes.
The second one, eh?
Yes.
Yeah, you're right. Sorry. Okay. So we shall have 2, 6, -5. The magnitude of them will be magnitude of 16 plus 9 plus 1. The other one is 4 plus 36 plus 25 cosine of theta. When you dot -4 and 2, you get -8 plus 18 plus 5 divided by square root of 26 square root of 61. Sorry, 61 plus 4, you get 65 is equal to cosine of theta. Finally, theta is going to be equal to 15 out of square root of 26 times 65. But the whole of this one, we get its cos inverse. Calculator, what angle do you get?
$68.60.
68
$60.
and you say this is what? Acute. Can you find for me the obtuse? Obtuse is 180 minus 68.60. So alpha will be
111.4.
and you say this is obtuse.
Teacher, are these definitions there in the logbook?
Yeah, these ones are there. Like D1, 2. Yeah, D1 times D2 is equal to magnitude of, they are there.
Okay.
You want to cram from the logbook.
Yeah.
So we have here another example. It says find the angle between the lines that is find the point of intersection of the lines. So first identify for me D1 and D2.
D1. 5.
5.
-1 and 1.
Correct. Identify D2.
2, 1 and 5.
Correct. So go ahead and get the angle. What answer did you get?
Theta is equal to 60.53.
Acute and obtuse.
119.47.
Okay. Now, they can ask you for the point of intersection, and they might give you the equations of the line in Cartesian form. So first extract them back into vector equations of a line. For example, line 1, the point there is, what is the point in the first line? What is the x coordinate? Of this line?
The first line.
The coordinate of x?
1. Negative 1.
Are you sure?
-1.
Why is it -1?
For x plus 1. It's supposed to be x minus.
Yes. I want you to
x1.
hear that mathematics. Okay, you're now fine. And the y coordinate?
-2.
Then the z?
Then 6.
Eh?
6.
+6. Okay, thank you. Plus lambda, the direction vector is 5.
5.
-1.
And 1.
Okay. The second line, give me its point.
6. 3. 0.
Now, this time round here, you can say maybe the coefficient or the scalar multiplier is gamma. Or if you want lambda, you say lambda 1, lambda 2. The scalar multiplier is different. So it has which direction vector?
2, 1, and 5.
2, 1, and 5. Now we have said for the lines to intersect, R1 should be equal to R what? So we shall see that -1, -2, 6 plus lambda into 5, -1, 1 should be equal to 6, 3, 0 plus gamma into 2, 1, 5. Therefore, you will get 5 lambda minus 1, -2 minus lambda, and 6 plus lambda is equal to 6 plus 2 gamma, then 3 plus gamma, and then 6. This is 0, eh? 0 plus 5 lambda. So you say 5 lambda. Now, because the two brackets are equal, those lines are equivalent. So pick any two and solve simultaneously. 5 lambda minus 1 is equal to 6 plus 2 gamma. You will get 5 lambda minus 2 gamma is equal to 7, equation 1. Then I can pick the last one. The last one says 6 plus lambda is equal to 5 gamma. So 5 gamma minus lambda is equal to 6. So I'll have 5 gamma minus lambda is equal to 6. From Roman 2, you can make Roman 2 the subject and make lambda the subject, which is 6 minus 5 gamma. Then you substitute using substitution method to solve the what? To solve the simultaneous equation.
Teacher, we're using Roman 2.
Yeah, I'm using Roman 2, yes, sorry.
Isn't gamma supposed to be lambda 5 lambda?
Hey, this is 5 what?
5 alpha minus 6.
This is 5 gamma.
5 alpha.
I'm using this one and this one.
Then the anti down here, the second equation.
Yeah. 5 gamma minus lambda is
Then
6.
it's supposed to be 5 gamma minus 6.
It would have been 5 gamma minus, here. You are right, thank you. So it is 5 gamma minus 6 is equal to lambda. So we saw 5 lambda minus 2 gamma is equal to 7. So 5 into 5 gamma minus 6 minus 2 gamma is equal to 7. 25 gamma minus 30 minus 2 gamma is equal to 7. We shall have 23 gamma is equal to 37. Gamma is equal to 37. Now, this same question, can answer another question. Show that the lines intersect. So this is 37 out of 23. Then you can substitute back to find lambda. So 5 gamma, which is 5 times 37 out of 23, minus 6 is equal to lambda. 37 times 5, that is 150 plus 35, 185. Minus 120, 138 over 23 is equal to lambda. Therefore, lambda is equal to 138 minus that, you get 140, you get 141, 147. Then when you substitute those items back here, where I ticked, they should give you the same answers on both sides. If they give you the same answers on both sides, they confirm that they intersect. But if they just ask for the point of intersection, don't waste much time. Just stop at gamma. Then you come and substitute here gamma. Or here. So that you get 6 plus 2 into 37 out of 23. 3 plus 37 out of 23. And 5 times 37 out of 23. Then you get the answer. You investigate those items. If they give you the same answers. Actually, to confirm, you don't need to, for testing whether they give you the same answers. Okay, you have to test all of them. But for now, let us just use only the first row to check whether the I is the same. If the I is the same using that gamma and lambda, then we're on the right track.
The gamma, lambda, I mean the lambda is 47 over 23.
7?
47 over 23.
Oh yes, I missed the one. Okay.
I give the same answer.
Okay, then we are right. So ideally, you should have that in mind, that in case they have asked you for point of intersection, you just need to get one of them. When you get alpha or gamma first, substitute back, the point you get is the point of intersection. But if you want to prove that they intersect, then you show that you get the same point when you use lambda, which you've got, and show that you get the same point, use the same point and find what? Gamma, and you confirm having the same point achieved. So I have that.
Wait.
Huh?
Which same point?
Yeah, which same point? And the point you've got, you've said these ones are the same, not so? This one.
Yes.
And this one. Yes. So you prove, for example, what have you got here?
It was 9.22.
Even this side has 9.22, not so? So when you prove using lambda, for example, you get 9.22, 1.33, 4.14. Even when you use gamma, those items should all correspond to 9.22, 1.33, 4.14. If they do qualify and they're all the same, it means there is a point, that is the point of intersection. And it means you have showed that the lines actually do what? Intersect, because the point of intersection is the same. When they just ask for only the line point of intersection, then just go ahead and only equate them, and whatever you start with or you land on first, whether lambda or gamma, is what you use to find that point of intersection. But if it is a show, you have to use both lambda and gamma and substitute back and confirm whether you get the same answer. Then at times they can ask you to show that the lines are perpendicular or the lines are parallel. Perpendicular lines and the parallel what? Lines. If lines are perpendicular, then these lines, one will have a direction vector d1 perpendicular to another direction vector d what? D2. So when you dot d1 and d2, you must get what? 0. Do you remember the condition for perpendicular vectors? When you dot the two vectors, you must get what? 0. Then for parallel vectors, when the vectors are parallel, you'll have d1, you'll have d2. So if they are parallel, it means the dot of the vector d1 and the dot of the vector d2 must give you the magnitude of d1 times the magnitude of d2, because the angle between them is 0. So you just dot their direction vectors to find out which one is parallel and to find out which one is perpendicular. When you confirm which one is parallel and which one is perpendicular, then you can always have the solution for which lines are perpendicular and for which lines are
parallel.
So that is as simple as that. In case you land on questions talking about the same, you should be able to try them out. So today for now, we can stop at that. Shall start from there. This week, let me look at paper 1. Then next week, I'll look at paper 2, the whole of it. So you go and visit numbers in the question bank on lines only. Even if it's saying a line and a plane, don't do, but look at only lines only. Try some out. WhatsApp me those that challenge you. Then WhatsApp me also those that which you will not have covered yet for a line, so that maybe by tomorrow I introduce their definitions and take a look at them.
Okay.
Okay. Yeah. So, because today is March, today is Thursday. So we shall meet again at 8 for physics, 8 p.m.
Okay. 8 p.m.
Yeah, 8 p.m. Okay, then I will send you some work also, some more numbers for you to check out.
Okay.
Alaikum, mumaze okusiba. Mumaze okusiba. Hello? Mumaze okusiba. Are you right? Mbale mwakasibako bumere. Eh? Kale. Agenze.